Hi, I'm Atin.
Hi, I'm Amol.
We're 8th graders. We are working on a problem which involves getting a hungry bird to its food the fastest. The bird is sitting on a 20-foot tall tree. There is a 40-foot long ground, and on top of that, there's a 5-foot tall fence. The bird wants to get the food and then go sit on the fence. As you can see, the bird can take many paths, but the bird wants to take the fastest path. There are infinite paths, so how do we find the shortest? Of course, the shortest path would be a straight line from the tree to the fence. But you have to remember the bird wants to get the food and then go sit on the fence. You could measure all the lengths with the ruler, but there are so many.
I can make a suggestion. In the sport cricket, the pitch is about 20 meters long. And a good length ball is pitched 5 meters from the stumps. This is about 3/4 down the pitch. You can apply the same concept to this problem. So I think we should start measuring from the 30 feet mark, which is also 3/4 down the 40 feet ground.
I've measured some of the lines around 30-foot mark, and I've measured that the green line, which goes to 32 feet mark, is the shortest.
Okay, so I tried the problem, but instead of graphing, I made an equation and then I put the equation in my graphing calculator. So we can let the point where the bird flies to be x, and then the remaining distance on the ground be 40 minus x. And we're trying to find out the distance of this line and then this line, because that's going to be the bird's flight path. So for this question, I used the Pythagorean Theorem, which is a squared plus b squared equals c squared, or c is the square root of a squared plus b squared. For the Pythagorean Theorem to work, you have to be working on a triangle, and the triangle needs to be a right triangle as well. So for this triangle, it'd be 20 squared plus x squared is equal to this, is going to be equal to the square root of this. And then for this one, it's going to be 5 squared plus 40 minus x squared, and then the square root of that is going to be this line. So this is the equation that you get at the end. And then I put the equation into my graphing calculator, and I got that x is about 32 feet when the bird hits the ground. So as you can see, x is 32, and Uthin got this as well. So now we know that the spot that the bird should fly for it to get the fastest flight path is going to be at 32 feet. Thank you for listening to our presentation.